go to the next part of this. We ended yesterday talking about properties of logarithms. We're going to continue with that. I know we always need a little bit more review with, writing in terms of log of constants, so I wanted to start off with that. We want to express these logarithms in terms of log 2 and log 3. So what I do is I start with 96. I want to do the prime factorization, not the prime factorization. I want to factor 96 and write it just in terms of 2's and 3's, right? So 96 is 2 times 48, and that's 2 times 24, and that's 2 times 12, and that's 4 times 3, which is 2 times 2, right? So here, can I just write that as 2 times 2? Right? Well, you have to break down 96 into what is made. So now, how many 2's do I have? 1, 2, 3, 4, 5. So this is equal to log of 2 to the 5 times just the 5. So it's important here that you do it that way, and you write it in terms of exponents, right? Just the way you learned how to do it way back in the day in middle school or, right before pre-algebra. And then I want to expand this, so it's going to be log 2 to the 5 plus log 3. And then, of course, the 5 has to come down, so it's 5 log 2 plus log 3. You are seeing that if you do it, the long way, basically, if you don't write it in terms of exponents, and you say 96 is equal to 2 times 2 times 2 times 2 times 2 times 5, then you have log of 2 plus 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 log of 5. But that's all 5 log of 2, right? So this is just a much quicker, cleaner, preferred way of doing it. Okay. Next I have 32 over 9. And I want to do those two independently of each other. So first I say, okay, this is log of, okay, so the 32, how can I write it in terms of 2's or 3's or both? It's 2 to the 5, and then 9 is 3 squared. So now I have log 2 to the 5th minus log 3 squared.
I have a question.
Yeah.
If I vision like that, where it's like vision, but there's like 2 different, like 9 and then x. Would it be log 32?
Yeah.
Log 32 minus log 9 minus log x.
Yes. If it was 9x on the bottom. If it was not yet, it'll be log 9 minus log 9 minus log x. Okay? So we bring the exponents down to become coefficients, and there you have it. Okay? Alright, here I need to express in terms of ln of 5 and ln of 3. And so this first one, we're going to go ahead and write it as an ln, not a log. And I need 5's and 3's here. So we're going to break 75 down into, just because I knew it, yeah. And some of you out there might not have one for 75, or there's some of you might. And maybe one day you're feeling a little hungry and you feel like you need to do it, and another day you feel like you don't. It's fine, okay? But do show me the broken down version. So 3 times 25 makes 75. And that's 5 times 5. So do show me that this is ln of 3 times 5 squared. And now it's ln of 3 plus what? ln 5 squared? ln 3 plus 2 ln 5. Okay? This is on the no calculator section. So let's do ln of 45. How does 45 work out with 5s and 3s? It's, 9 and 5, which is 3 squared. So this is ln 3 squared times 5. And so at this stage, this is ln 3 squared. Sometimes students will say, hey, can I just write 2 ln of 3 from there? Sure. Okay? Or we go another step. 2 ln 3 plus ln 5. Okay? Okay. So, we're going to do some more expanding. Right? So this is log base 2 of 4 plus log base 2 of m squared plus log base 2 of n to the 5th. So those of you who missed yesterday, well, I mean, you were here for most of the lesson anyway, but this is another recap. Okay, what does that first term give me? 2. And then 2 log 2m, 5 log 2n. Which 2? You just can't see it. It's so tiny. I didn't leave enough room for me. Okay. Okay. Next. This is my favorite one. By far. How many elements here? 2, x, y, 5, z. So 5 total. So, okay, so let's see. Log of 2 plus log of x plus log of y squared minus log of 5 minus log of root z, which is z to the half. Good. Okay? And so now, log of 2. Okay. It's convention. You don't have to do it. I won't take points off for this, but it's convention. You see how we have log 2 and then variable, and then log 5? It's convention to write all the constants next to each other. So why don't we do that, right? Like just bring this down here, minus log of 5, just switching some, the order around. Plus log x plus 2 log y minus half log z. That's totally fine. I'm just how it works out there in the real world. What we're going to do now is literally the opposite. So if, we were to rewind this video of the last problem we did, literally just like undo it. So what would happen? All of the exponents would go up, and then this would just condense to this, right? So if we wanted to do that now, the opposite of expanding, we would be condensing a logarithm, okay? When you condense a logarithm, you rewrite the expression so that you end with one logarithm versus however many elements there are. You have to make each coefficient into an exponent. And then each element which was added, right, will be placed in the numerator. So each element which is added will be placed into the numerator. And each element which is subtracted into the denominator. So here, right, you know, the negative, like with the 5 and with the z, they would go in the denominator, but everything else would be in the numerator. So let's do that. First, we have to make coefficients into exponents, 1 and 2. So I have log 4 x to the half minus log 4y cubed. Now I need one log. Log 4. This one has a plus, right? It's a positive. So the x will be in the numerator. Now if it's x to the half, it's the square root of x. And then the y cubed has a negative, so it must go downstairs into the denominator. Okay? Yeah. Okay? Cool, right? Huh? All right. So, exponents first. This is ln a to the 5th plus ln b to the 6th. So this is ln a to the 5th times b to the 6th. You can do it that way or put parentheses. Questions? Not that bad, huh? Logarithms are not that bad at all. They're very, very doable. Okay, so let's go one more. Exponent, exponent. ln 5 squared plus ln a minus ln b cubed. ln 5 squared times or divided by a times a divided by b cubed. But you do. So that's what I was going to say next. Now what to do about the 5 squared? Rule of thumb for my classes, as long as you get a number in the hundreds, 3 digits, multiply it out. But once it's a number that's going to give you like 1,000 something or 2,000 something, leave it in exponent form. So this one, we're going to simplify it as ln 25a over b cubed. Okay? Just so everybody's on the same page and we have our expectations and it's uniform and standard and blah, blah, blah. Okay. Here we go. Log base 3 x to the 4 minus log base 3 y to the 1/3. There's a root happening there. Log base 3. Okay, for x, that's the positive. It goes in the numerator. Then I have a minus, so I need to have a denominator. Y to the 1/3 is cube root of y. Okay? And now that we don't have to rationalize denominators anymore, that's totally cool. Okay? Yeah. Alrighty. Okay. So here, now we have expressions. Oh my goodness. The 2 becomes an exponent. Log 3. X plus 1 squared minus log 3x. Alright, tell me. Log 3 of what? X plus 1 squared over x. This is good enough. That's it. However, if you somehow neglect to put the parentheses here, it's completely wrong, right? Because now this is just x plus 1 squared, which is x plus 1, right? So you have to put the parentheses, okay? All right, go ahead and do F. I'm going to give you 20 seconds. Okay. What do we think? Somebody, anybody? Somebody, anybody? Somebody over there. I haven't heard anything from over there.
ln parentheses x minus 4 to the power of 6.
Right.
X to the power of 6.
Right, times x cubed. Okay? So, it's x minus 4 to the 6 times x cubed. And you know what? There's so much happening there that I just like to compact it in brackets. You don't have to do that. I mean, I think it's nice if you do, though, right? Because, or look, if you would write it like this, ln of x cubed, x minus 4 to the 6, it kind of looks more compact. That's more conventional. Or the one at the top. Yeah. Yeah. You don't have to. You don't have to. Like, this is good enough. If you distribute it, you have to be careful, though, because it'll be x squared plus 2x plus 1. It's not x squared plus 1. Because this is, it's x plus 1 times x plus 1. So it'll be x squared plus 2x plus 1. So beware of those things. Here's the catch-22. If you leave it like this, it's fine. If you attempt to distribute but make a mistake, then you get points taken off, right? So that's a little bit of a situation there. Okay. Change of base formula. So it's possible to, if you have log, base 6 or 4, it's possible to change the base into some other base, or let's say base 10, right? So we can change this, we can change the base, which is a 6, to a base 10, and it will be a fraction. And the fraction is log base whatever you want, we're going to make it a base 10, of this number, always that number first, over log of the other number here, 6. So that's a formula to do. And so now what I've done is, I had a logarithm with a base of 6. What I've done is I've changed it to a logarithm with a base 10. Okay? Sometimes it's worthwhile to do that. And so after this, you can evaluate it using a calculator. It used to be that one of the reasons, not the entire reason, one of the reasons to do this was because we couldn't enter another base into the calculator. They all had a base of 10, so we had to change the base. Now with your Inspires, you can evaluate both ways with the calculator. So that's kind of a moot point. However, we're going to be doing these with variables in a second. So let's go in here. And so we're going to do log. And let's just put in base 6 of 4. And that's that. Right? Or here's how you're going to do the other way. Or look, if you were to do log, just go in here and do log 4 in parentheses divided by log 6, right? You see how it changes it to base 10 and it gives you the same value, right? So when log base 6 of 4 or log 4 over log 6, right? As long as you change it to the same base, that's another way to do it. So let's go ahead and do the next one, and I'm going to skip putting in the calculator. But how would you rewrite this? It would be log of what? 4212 over log of 4. Now, what if I were to give you, let's say, log A of 7. How would you rewrite that? Log 7 over log of A. Okay? Okay. All right. So, another handout here. This handout for you guys will be due next period.